Okay, so we are going to continue and do this animation. So we've been looking at the winds and the pressure centers and the three cell structure. So this animation, I hope it works. I'm doing it as a screen capture. So let me clear all of that and start with the idealized Hadley cell. Idealized because again, we are ignoring the asymmetries and we are just assuming Earth is an aqua planet, so the heating is right on the equator and the low pressure and the warm temperatures are also on the equator. So you can see that the air is rising on the equator where it's very warm and the pressure is low, and the rising air hits the ceiling and then moves towards the pole because we are looking at the zonal mean meridional section again. And there is an additional thing that is done here that I haven't mentioned yet. I kept saying air moves towards the poles as it hits the tropopause, but here you can see that actually it is sinking somewhat towards the surface as it goes away from the equator. Why is that? Basically because as you go to higher latitudes and the air gets colder and colder, it gets denser and the atmosphere fits into a smaller volume. So the tropopause, which is at about 12 kilometers in the deep tropics, actually ends up being about 8 kilometers by the time you reach high latitudes. So that's why here you can see that uh, the air that is going towards the pole is actually sinking.